Okay, a lot of those calculations are very applicable to liquid growth regulators when we are doing foliar sprays. Sometimes, however, or if we're making up solutions that we're going to do bulb soaks in, or that we're going to do, the plug dips or things like that. Sometimes we also will do substrate drenches where we're pouring the growth regulator into the soil, into the container. And you may see recommendations that say pour 50 mils of a 200 part per million solution per pot. In which case you just make up however much volume you're going to need of a 200 part per million solution and apply that amount to the container. So it's a part per million calculation. Instead of spraying, you're pouring it on. Sometimes, however, you will see a recommendation that rather than being a part per million calculation, it tells you to put a certain number of milligrams of active ingredient per pot. So in other words, into each container, we want to put a certain number of milligrams of active ingredient, and that's the basis for that. For example, on lilies, you'll often see the recommendation of apply in a 6-inch pot to apply 0.25 milligrams of active ingredient per container. And the volume of liquid you apply, it kind of is variable, but you apply enough to basically have that solution work its way down to the container. So you might apply a couple of hundred mils or something. But regardless of the volume, you're doing it so that you put that much per pot. Now, in this particular case, then, if you read this and you're following this kind of recommendation, this is not a part per million calculation. So we do this kind of a thing differently. And let's look at a real-world scenario. You're doing hybrid lilies, Asiatic lilies, Oriental lilies, Easter lilies in pots. And the recommendation says 1/4 milligram per container. That's very common. And let's say I've got 10,000, let's just say they're Easter lilies. I have 10,000 Easter lilies in 6-inch pots. The recommendation is 1/4 milligram of active ingredient in A-rest. A-rest is commonly used per pot. So in other words, we want 1/4 milligram, and the active ingredient in A-rest is ansimidol. So we want basically 1/4 milligram of ansimidol per pot into that, with enough solution into that soil to sort of saturate down into the pot. Well, again, this is not really a part per million calculation. First thing we need to do, how much liquid do you need to apply to a 6-inch container so that you kind of get it to flow down without a lot washing out the bottom? And some of that is is a little experience, really, what kind of mix you have, those kinds of things. If you only apply a little bit of liquid, it doesn't move down into the root zone. If you apply too much, it may flow out of the bottom and some of the active ingredient goes out and it's wasted. But, probably on a 6-inch container, 100 to 200, just depending on the growing media. So let's say we decide we want to apply 200 mils per pot, 200 milliliters per pot. That's a good amount that will go down into the substrate, almost to the bottom of the container, saturate that area around there without really draining out. I'm going to change that by the... So we want 200 mils per pot, so that I don't get some huge numbers. Don't let this confuse you. 200 mils is equal to the same thing as 0.200 liters, okay? And I'm just doing this little conversion here because otherwise I'm going to get into some huge numbers. So we're going to put 0.2 liters per pot. We got 10,000 pots. Okay? That means the total volume of solution we're going to need to cover that crop. We're not even talking about the growth regulator, it's just how much liquid we're going to need. We will need 2,000 liters total in order to put 200 mils per 10,000 pots. So that's our total volume here. Now we want 0.2 0.25 milligrams of active ingredient per pot, and we have 10,000 pots. That means we will need 2,500 total milligrams of active ingredient. When we make up that 2,000 liters of solution that we're going to spread out, it needs to contain a total of 2,500 milligrams active ingredient, or of ansimidol. Again, just do that backwards. If I've got in that tank, that solution, 2,500 milligrams, and I divide that by 10,000, if I'm doing it uniformly, I'll get a 1/4 milligram per each of those pots. Now the question is, how do I get 2,500 milligrams of active ingredient, of that ARES solution? How do I measure it out? What do I put into that tank that I'm going to eventually bring up to the 2,000 liters? Well, remember that ARES, from the previous calculation, it's a 0.0264% solution. We multiplied that by 10,000, and that meant we had a 264 ppm, or a 264 milligram AI, or ansimidol, per liter solution. So a liter of ARES contains 264 milligrams. So we just divide. And if we divide the 2,500 by the 264, we come out with 9.5. Okay? Just dividing the way we had before. So 9.5 liters of ARES will contain 2,500 milligrams of ansimidol, the active ingredient. We put that into the tank. So the ARES goes in. Okay, and then we add the water and bring that up to a total. So basically what you're going to do is add 9.5 liters of ARES and 1990.5 liters of water, but bring it up to the 2,000. Now you've got your solution, and out of this, either, we usually have a little device that will pump a certain amount. We can walk along and squeeze, and it pumps out a certain amount. If we then take this solution and we apply 200 mils, or 0.2 liters, per pot, there will be enough liquid in here to cover the 10,000 pots, and each 200 mil aliquot, as long as we've got it mixed well, will provide that 1/4 milligram into each pot. So that's not even really a part per million calculation, but it's an example. If you're seeing recommendations where they're telling you to do a certain milligram active ingredient per pot, that's basically how you do that.